This is problem 8.6 out of Brigham and Houston, Fundamentals of Financial Management, Concise 9th edition. Here we're calculating and comparing expected returns, standard deviation of returns, and coefficient of variation for two sets of stock. They give you some of the numbers as a check number. Alright, but we'll start with the probability. If you multiply the probability times the returns for each of these, and I'm going to use so this would be the expected. I'm going to multiply using the sum product function. Sum product, this array, multiply that column of numbers, comma, times that column of numbers. That's 12%, and that's given in Part A. Calculate the expected rate of return for stock B. In parentheses, I tell you that the rate of return for stock A is 12%, 0.12. So that's just a check number to make sure you don't do it wrong. Using the sum product function, the probabilities times the rate of return. And so the rate of return for stock B is expected to average 14%. Alright, Part B says calculate the standard deviation of expected returns. Okay, and do it for A because they already give you the sigma or standard deviation for B. Well, I'm just going to do them both. So start with the mean deviation. Mean deviation for A, and that would be the return minus the average return. And I can do this for both the mean deviation for B. Alright, so the first step in mechanically calculating the standard deviation is to calculate what the deviation is, and that simply takes this number minus the average, this number minus the average, and then plots those down through here. Do the same thing for B. Squared deviation for A is simply take that and square it. Square deviation for B, take that number and square it. I'll just copy these down. Alright, so now I've got all those squared deviations. To get the variance, sum product, I'll take the weights times the value in each of the columns. Notice the judicious use of the dollar sign in here. When I copy this over, it'll keep this set of numbers because of the dollar sign, but it'll automatically adjust to multiply column C, or column B rather, times the numbers in column J. Alright, so there's my variance. My standard deviation is that raised to the 0.5 power, or the square root of it. Alright, I'm going to format these as a percent. And you can see, now they gave me the sigma for stock B at 20.35, and I must have done it right because I got the right answer. And the standard deviation for stock A is 12.2%. Now calculate the coefficient of variation for both of them. Alright, so the mean return, or the expected return, the standard deviation of return, and the coefficient of variation is the standard deviation divided by the mean. Okay? And this will be for stock A and for B. Alright, the mean return for A is 12%, 0.12. Same number as 12%, I'm just going to format it for percentage to 2 decimal places. And I calculated the standard deviation as 12.2, so the coefficient of variation would be the standard deviation divided by the expected return or mean return. And again, I don't know why Excel does that, but it's done it since I've been using it. We do the same calculation for B, a 14% return, but a much wider variation in the return. Okay, so some investors would think that stock A is less risky because it's got less risk per unit of return. All right, and stock B has a higher expected return, but a lot more risk. So the risk per unit of return, that's the coefficient of variation, on B is much higher. All right, so I don't see how anybody could say that stock B is being less risky than stock A. It's the exact opposite. Stock B is riskier, more risky than stock A.